In this video, we want to evaluate an indefinite integral has a radical expression in the denominator. You can pause the video and see what method you would use, and then I'll be back. Anytime you have a radical expression in the denominator, depending on what type you have, you could have a trig substitution. But if you see the trig substitution is not going to work, I would always try to simplify it. In this case, rationalize the denominator and see what happens. The conjugate of this denominator is radical x plus radical x plus 1. Just like a minus b times a plus b is a squared minus b squared. If I multiply the denominator by the conjugate, I'll wind up with x minus parentheses x plus 1, and then multiply that same expression times the numerator. See what we get. So here we have it then. So multiplying by the conjugate of the denominator, or you can multiply the denominator and the numerator. So in the numerator, I'm simply going to have the square root of x plus the square root of x plus 1. In the denominator, multiplying radical x minus radical x plus 1 by its conjugate just gives me the square of the first term, which is x, minus the square of the second term, that's the square root of x plus 1 squared, will give me just x plus 1. And of course put the parentheses here. So if I simplify this, I have a x and then a minus x and then a minus 1. So the x and the minus x cancel, I get minus 1 here. So all I have is the denominator, or the numerator, divided by negative 1. So this will be the integral then of radical x over negative 1 will give me negative radical x. And then square root of x plus 1 over negative 1 gives me the minus. So I'll wind up with the integral of negative square root of x minus the square root of x plus 1. So you could break this up into two integrals and use a u substitution for the second integral of minus the square root of x plus 1, letting u equal to x plus 1. But that would mean du would equal to dx, and you basically have the same sort of thing. So the best thing to do here is just use the power rule for integrals. And I'm going to rewrite this. Instead of the square root of x, I'll write that as x to the 1/2 minus x to the 1/2 here. Instead of the square root of x plus 1, I write that as x plus 1 to the 1/2. And like I said, just use the power rule for integrals. This will be equal to, that's going to be minus x, and then we add 1 to the 1/2, it gives me a 3/2. Divide the coefficient negative 1 by 3/2 gives me a negative 2/3 in front. Same thing over here. Add x plus 1 to the 1/2. Add 1 to the 1/2 gives me 3/2. Divide the coefficient negative 1 by 3/2, I get a negative 2/3 plus the constant of integration. And this should be your answer here. Negative 2/3 x to the 3/2, then minus 2/3 x plus 1 to the 3/2, and that's your answer. Thanks for watching. We'll see you next time.